So today we will see the very first chapter, that is called thermodynamics. So what is thermodynamics? This thermodynamics is nothing but a branch of physical chemistry which deals with the study of conversion of heat into energy and vice versa. That is, in thermodynamics, we study the conversion of heat into energy and energy into heat. There are various forms of energy that we know, that is kinetic energy, potential energy, nuclear energy, rotational energy, vibrational energy, and so on. So this thermodynamics term is a branch of physical chemistry which deals with the study of conversion of heat into energy and conversion of energy into heat, that is simply called as the vice versa. This term thermodynamics is divided into two parts. One is thermo, which means heat, and another one is called dynamics, which means to do work. So by using heat, we can do some work, or when work is done, at that time heat may be generated. So here this thermodynamics is nothing but a branch of physical chemistry which deals with the study of conversion of heat into energy and vice versa. Now, why it is important to study thermodynamics? There is a lot of scope for study of thermodynamics. The various important laws in physical chemistry, such as the Van 't Hoff law, then relative lowering of vapor pressure, or the distribution law, and so on, these all laws in chemistry are based on the concept of thermodynamics. And here it becomes essential to study this thermodynamics. Then another important point is that this thermodynamics helps to guide us or to predict whether a process will occur or not. That is studied in terms of a few factors such as the internal energy, enthalpy change, internal energy change, Gibbs free energy change, entropy change, and so on. So these concepts, that is related with the second point, that is thermodynamics tells whether a process will occur or not, that we can see in the second part of thermodynamics. Now again, this thermodynamics also gives information about the extent to which a process will occur, that is again predicted with the help of thermodynamics. And here therefore it becomes essential to study this thermodynamics. So for this thermodynamics, the various important laws in chemistry, several laws are there which are completely based on thermodynamics. Then this thermodynamics also gives information regarding whether a process will occur or not, or this thermodynamics also gives information regarding the extent to which the process will occur, and hence it becomes very much important to study thermodynamics. Now, what are the limitations of thermodynamics? Now, this thermodynamics is applicable only for the macroscopic properties. So what are macroscopic properties? Macroscopic properties are nothing but the properties of bulk, that is pressure, volume, and so on. So this thermodynamics concept is applicable only for the macroscopic properties, and it completely ignores the internal structure of matter. We know that the internal structure of matter is composed of atoms, ions, molecules, and even the subatomic particles, that is protons, electrons, neutrons. So all these internal structure of matter is completely ignored in this thermodynamics, and it is only the science which is related only with the properties, macroscopic properties of matter, that is called bulk properties. Then another important limitation of this thermodynamics is that it does not take into consideration the time factor. So a thermodynamic process may be completed within a fraction of a second. It may require several minutes, or it may be completed within several hours, or it may require complete years of times for its completion. So there are only two limitations associated with this thermodynamics, that is this thermodynamics is applicable only for the macroscopic properties, first thing, and second thing is that thermodynamics does not take into consideration the time factor. And whereas we know that this time factor has a lot of significance in chemical kinetics, which you have studied previously in the 12th standard, where this time factor is very much important. That is in case of chemical kinetics. So where we do study there the rates of chemical reactions. So in thermodynamics, this time factor is completely ignored. And another limitation of thermodynamics is that this thermodynamics is applicable only for the macroscopic properties, and it completely ignores the internal structure of matter. Now we will see some of the basic concepts related with thermodynamics. And these basic concepts are called what we say these thermodynamic terms. So what are these simple thermodynamics terms? That is system, surrounding, universe, boundary, phase, and so on. Then again we will see the types of systems, then based on the phases, types of phases, and so on. So let us consider these terms one by one. So what is a system? In thermodynamics, a system is nothing but portion of matter. Simply, it is nothing but portion of matter which is under thermodynamic study. So in this picture, you can see here, in the first picture, you can see here ice cream taken in a bowl or in a conical flask. In the second picture, you can see here some water is taken and that is getting heated from the bottom. So in the first picture, if this is solid state of matter, that is ice cream is there, and if I am studying the temperature changes or the thermodynamic changes associated with this melting of this particular ice cream, then that ice cream is my system. Understood? And in the second picture, you can see here just water is taken in a conical flask and that is getting boiled or that is getting heated from the bottom. So this water which is taken in this beaker is another example of system. So this system is nothing but it is simply the portion of matter which is under thermodynamic study. What is system? System is nothing but portion of matter which is under thermodynamic study. Anything that we study in thermodynamics, that is a system, right? The next concept is of surrounding. What is surrounding? Surrounding is the portion of universe. It is the portion of universe other than system. Portion of the universe other than system which can exchange energy and or matter with the surrounding. So it is the portion. So surrounding is what? Surrounding is nothing but portion of the universe other than system which may exchange energy or matter or both energy and matter with the surrounding, that is called with the system, that is called surrounding. So surrounding is nothing but portion of the universe other than system which can exchange energy or matter with the system. Now the third definition is of universe. So what is this universe? In Marathi, for universe we call as Vishwa, but that is something different here in case of thermodynamics. So universe is nothing but the combination of system and its surrounding. Simply, in simple language, it is nothing but the combination of system and its surrounding. So a system and its surrounding are combinedly called as the universe. System and its surrounding are combinedly called as the universe. So system plus surrounding, they constitute the universe. Now let us consider here, for the sake of understanding, let us consider here a simple example where I have taken a conical flask, and into that conical flask I have taken some water, and that is kept in a box. So here this water which is taken in this beaker is my system. The portion of this box other than this beaker, sorry, this conical flask, portion of this box, this inside portion other than this conical flask is now the surrounding for me. And this combination, this water taken in a conical flask kept in a enclosed cubical box, that is my universe. So universe, generally we say that universe, in Marathi we say that Vishnu, but it is something different in thermodynamics. So it is nothing but the combination of system and surrounding. Simple language, in simple language, This universe is nothing but the combination of system and surrounding. So up till now, we have seen the three concepts. One is of system, another one is of surrounding, and third one is of universe. So system is nothing but portion of matter which is under study, portion of the matter which is being studied in thermodynamics, that is the system. Then surrounding is what? Surrounding is the portion of universe other than system. Portion of the universe other than system which can exchange energy and or matter with the system, that is called the surrounding. And the third term is of universe, that is nothing but the combination of system and its surroundings. Then the next definition is of boundary. When we play cricket, there is some boundary that separates the players which are playing inside the ground and the spectators which are sitting inside the stadium. So here that concept is like similar to that boundary here also. So what is this boundary? In thermodynamics, this boundary can be a real or imaginary surface or line. What is this? Boundary? Boundary is nothing but an imaginary line or a surface which separates a system from its surroundings. So here in this, I have shown here a simple picture where in this simple picture, this sky blue region represents my system. This pink region represents my surrounding, and this line or this particular surface which separate the system and surrounding, that is called a boundary. So in physical chemistry or in thermodynamics, a boundary is nothing but a real or imaginary line or surface. In physical chemistry or thermodynamics, this boundary is nothing but real line or imaginary line or real surface or imaginary surface which separates system from its surrounding, that is called a boundary. Now the next definition is of phase. What is meant by phase? So phase is nothing but it is a simply part of the system. Phase is what? This phase is a part of the system. And how that part should be? That part should be firstly homogeneous. Homogeneous means that should be completely uniform. Then that second condition is that that part should be physically distinct. My eyes should observe that part as a distinct from other parts. So that is said to be physically distinct. And that should be again mechanically separable. That is, it should be separated by some mechanical operation, say filtration or evaporation or distillation and so on. So a phase is what? Phase is nothing but a part of system, and that part should be how much? How that part should be? It should be homogeneous, physically distinct, and mechanically separable part of the system. So phase is a homogeneous, physically distinct, and mechanically separable part of the system. Now let us illustrate this concept with some examples. Now let us suppose I have taken a beaker, and inside that beaker I have placed here a sample of pure water. Now this pure water, I can find it a uniform water is there, that is physically distinct. My eyes can check whether that water looks like different from this glass. Then that should be mechanically separable part of the system. So I can pour this water on ground, or in second picture we can see here water is there, and to that some pieces of ice are added. Now in this second picture you can find here two parts. The overall system is what? Water plus ice is now system. Water plus ice is system, and here this ice is looking like different from this water, or this water is looking like different from this ice. So here there are two phases. Now let us consider here third example, or even in the second example we can consider here a water, and if to that water some sand is added. Now that becomes a biphasic system. There are two phases inside that. Or let us consider here third example where where in this beaker two immiscible liquids are taken. So mixtures of two immiscible liquids, say water, toluene, water, benzene, water, and some say pet ether or ethyl acetate. So when some two immiscible liquids are taken, then there is formation of two phases. They are not miscible with each other, and there is formation of two phases, and therefore a mixture of two or more immiscible liquids constitutes two or more phases. Therefore, now if we consider air, which is nothing but a mixture of gases, we know that in air several gases are present. Say oxygen is there, nitrogen is there, then again some inert gases in trace amounts are also present. So mixture of gases, how many number of gases may be there, they completely form a gaseous phase, that is a single phase. So a mixture of n number of gases will constitute a single phase. So here phase should be physically distinct, mechanically separable, and homogeneous part of the system. So now, depending upon the number of phases, systems can be classified as homogeneous system and heterogeneous system. So this part we can see in the next lecture. Thank you.